Hello, myself Naveen Kumar Saini. In the course Wireless and Mobile Communication, code KEC 076. Today we are going to discuss in Unit 4 long-term evolution, and in short we call it LTE. So first, before going into deep knowledge about the LTE, we must know what is the birth of the LTE. So why this birth of LTE comes into the picture? There is a 3.5 generation technique, so which is used to handle the mobile data rate. So because as we are aware that in today's scenario, data rate is very big, because we are using the text messages, we are using the calling, we are using the gaming, video games and so on. So I mean, to process all these things, the data processing must be very high, right? And it means the data traffic is very large. So to understand all these processes, why I mean, to use to process the data rates, very high data rates, we have to come into the different generations in mobile communication system. So one of those is the LTE. Okay, so in that to come into the LTE section, we have to go through the UTRA and UTRAN, right? So this one is the starting point for the LTE in the long-term evolution, which was started in the 2004. So, but what was the objective, which we had just discussed, that it is to develop a framework for the evolution of the 3GPP, which is the third generation partnership project radio access technology, right? So this was the standard which is gained by the 3GPP people for towards the high data rates, low latency, and the packet optimization radio access technology. So these are the key points for the development of the LTE system. So in the 3GPP release 8, it was the specifications of the EPC, these are evolved packet core, so which was the part of the LTE system architecture, which consists of the E-UTRAN, which is the enhanced UMTS terrestrial radio access network, and this UMTS is for the third generation. Okay, this was for the third generation network, and along with the UMTS, which is enhanced version, plus the EPC. So this EPC is the evolved packet core network. So this was the basic architecture of the LTE system, which contains the E-UTRAN and the EPC. So what is the E-UTRAN and what is the EPC? We will come into when we'll go forward in this lecture, then things will be clear to all of you. But important point is we must know what is the significance of this E, right? This is an enhanced version of the UTRAN, right? So which was a network which was used into the 4G networks. So what are the targets for that? So in the LTE, there are some targets. So which we define in the theoretical values as well. So when we go for the practical values, so it will be lesser than that, but we have to set the target so that we can achieve that. So first target was packet domain services only are required for this, and that is a VoIP, voice over IP. So upon LTE, TCP/IP based layers, these are used in the these are expected to use in the when you're designing the LTE network. So in that, the higher data rate and the user throughput, which is expected that 100 Mbps downlink and the 50 Mbps uplink, and which is at the bandwidth of the 20 megahertz. So as we are little bit aware that about the LTE, there is a scalable bandwidths are there in the LTE system. So when we have the maximum bandwidth of the 20 megahertz, so out of for this 20 megahertz system, we are expecting which we have the 100 Mbps of the data highest peak data rate, and the throughput which is of 50 Mbps. And in that, this is the second one, and third one is the reduced delay or the latency, which is at the user plane latency, which is expected less than the 5 millisecond. Okay, so this is the expectation of our latency in the LTE system. Next is very important point which is take care about, that is the improved spectral efficiency. This is very important, and it is expected to be 200 for the active users in the cell at the 5 megahertz bandwidth. So as I said, in the LTE system there is the scalable bandwidth. So in that scalable bandwidth, the first one is the 5 megahertz of the bandwidth. So we are expecting the spectral efficiency must be high. So what is the meaning of the spectral efficiency? The meaning of that one is, in a given bandwidth, how much data can be processed, right? So it is gained by the spectral efficiency. Then we have to optimize the networks for the low mobility system, high mobility system, or highest mobility system. So for that, when we have the low mobility case in which the Doppler effect will come into the picture, so it is up to the 15 kilometer per hour. So this is the mobility speed of the any vehicle or the subscriber, so through which we have to optimize the networks, right? Second is it is supported with the high performance for the medium mobility. So medium mobility is expected about the 120 kilometer per hour, and it must be support for the high mobility system, which is of 500 kilometer per hour. So these are the some mobility scenario which have to take care of when we are talking about the LTE standards, right? And next target which is expected in the duration of the LTE system, that is the multimedia. So multimedia broadcast and the multicast services, these are expected results which you are expecting in the LTE systems. Then next is the spectral flexibility. Okay, so in the 3G system, as we are aware, we have the 5 megahertz of the wideband system in the 3G, that is UMTS, right? Now we have in the LTE system, we have the flexibility of spectrum, like scalable bandwidths are there for that in the LTE system. Just like the first bandwidth will be of 3.5, then 5 and 10, 15 and 20 megahertz. So these are scalable bandwidths which are given into the LTE standards. So spectrum utilization of the spectrum by using the different frequency bands is, this is a very good feature of the LTE system. Then we have another important feature for the transmission of the data, that is the multi-antenna configuration. So the example for that one, which we are little bit aware most probably, that is the MIMO, or it may be the massive MIMO system, right? And it may be the COMP. So this is a coordinated multi-point. Okay, so multi-antenna configuration means when we have the multiple antennas at the transmitter and the multiple antennas at the receiving side. So how much antennas can be taken at the transmitting and at the receiving side? This is one of the interesting research scenario in which many researchers are working on it. How many antennas can be adjusted at the transmitting side and at the receiving side? Okay. So last one, expected target for the LTE, that is the coverage. So coverage is up to 30 kilometer. So it is expected when we have a particular cell. So this cell coverage, right? So in that cell coverage for a particular LTE system, we have the high power transmitting antenna. So what is the coverage area for that? So in the LTE system, it is 30 kilometer. But in the 3G system, it was a scalable, like 5 kilometer, 15 kilometer, 20 kilometer, and then the 30 kilometer. So the maximum coverage will occur when we have the LTE system, that is the up to 30 kilometer. So these are range of that. So another performance requirement in the LTE system. So first one is the peak data rate. So the peak data rate is expected for the downlink, that is 100 Mbps. For uplink, this is a 50 Mbps. And for this is for 20 megahertz of the spectrum, right? So this is a maximum spectrum size, so which is expected in the large scale of the 20 megahertz. The downlink data rate must be of 100 Mbps, and the uplink data rate is for the 50 Mbps. So I hope that all of you are aware about the uplink and downlink. Uplink is from the base station to the mobile phone, and this is a downlink, and the uplink is from the mobile phone to the base station. Okay, so this is the data rate, and this is the forward and reverse direction respectively. Then the mobility support, it also support the mobility scenario where the 500 kmph, the maximum speed of the vehicle or the subscriber, but it is have to be optimized for the speeds from the 0 to 15 kmph. So this is the maximum theoretical value which is expected, but in the real life, when we have slow speed or the low speed, for the low speed, when it is a standstill, then 0. When there is a pedestrian subscribers are there, then it is expected to the 15 kmph. Okay, so then we have next is the control plane latency. So in the control plane latency, there are two types of latencies, are the user plane latency and the control plane latency. So here the transition time for the active state is there, so which is expected that 100 milliseconds. This is for the ideal to active. Then we have the user plane latency, so which is expected about the less than 5 milliseconds. So latency must be as low as possible. Then control plane capacity, which is 200 users per cell, and this is the case when we have the 5 megahertz. So 5 megahertz of bandwidth is expected in a given cell. 200 users, minimum 200 users can be accommodated into the system, into the area. Then the coverage, here we have for the cell size, we have a 5 to 100 kilometer with slight degradation of after 30 kilometer onwards. Okay, so as we said, up to the 5 to 30 kilometer, the coverage will be okay in the if we talk about the cell size, right? So receiving signal at the cell edge up to 30 kilometer, it's okay. But when we are moving further of 30 kilometer up to 100 kilometer, so in that case the signal strength will be reduced. Okay, then we have the spectral flexibility, as I said. So in that the first is that is 1.25, then 2.5, 5, 10, 15 and the 20 megahertz. This is one of the unique feature in the LTE system where the spectral efficiency can be used in the scalable manner. So these all are the targets for the LTE system. When we design any networks in the LTE, then we have to think about, and we have to be theoretical values we have to be expected, that after practical we must get all these things. Okay, so now come to the next architecture of the LTE system, right? So in the left hand side you can see in this diagram that this is a UMTS 3G networks. This is given here. So in that the RNCs are there, radio network controllers, which is here you can see the node Bs and the RNC radio network controller, which is connecting between the SGSN, that is your servicing GPRS support node, and the GGSN. So this one is the gateway GPRS support node. So I will discuss all these things into the UMTS 3G network, but I am interested right now about the LTE system. Okay, so because this is the advanced version of the 3G, so this one is the 3G network, and this we are coming into the towards the 4G network, but in our practical thing we say this is the approx 3.9 G network. This is not the fully 4G network, this is a 3.9 G network. It is given in the literature as well. Okay, so in the LTE system we have the scenario where it is combined between, it is combination of E-UTRAN, okay, and then we have the EPC, which is E-UTRAN, evolved universal train radio networks, and we have the EPC, this is the evolved packet core network. So there are two parts of the LTE architecture. So in which the lower one, below one is the E-UTRAN, as I said. So it is used for all the processing of the OFDMA system occur into this E-UTRAN. So the OFDMA concept which we have discussed in the previous lecture as well, OFDMA system. So OFDMA system is used into this network where orthogonal frequency division multiple access techniques are involved in this for the multiple access of the common channels. Okay, so in this we have the E node Bs. So these are the E node B is the E-UTRAN E node B, right? This is a thing which you must be aware that. So what is the difference between the 3G network and the 4G network? The basic difference is we have the RNCs, which is the radio network controller in the networks, but this thing is inbuilt into the A node B as well, right? So there is no another separate block of the RNCs in the 4G network. So E node B is self-sufficient to control all the data processing between the different E node Bs. So we can process the data between one E node B to second E node B and so on between all the E node Bs which are deployed into the network. So this can be taken care by the itself, all the controlling parts, maybe call forwarding, data processing, gaming and all this data. So this can be processed for that, right? So this is mesh network as well between the different E node Bs. Okay, so there is a in the second part we have the MME and the SGW and the PGW. So MME is nothing but this is the mobility management identity. So this is the mobility management identity, and along with it we have the servicing gateway and the PDN, packet data network gateways. Okay, so here we see in this below one we have the interfaces. So how these different E node Bs can be interfaced with each other. So these there are different type of interfaces are there, that is the X2 interfaces we call it, between the different E node Bs. Then we have, so this data link layer and this data link layer data will be processed through different E node Bs. So this link of OSI can be used in the X2 interfaces. Next we have the S1 interface. So this S1 interface is in between the E node B and the MMEs. Okay, mobility management identity. So the for connection between the E node B and the MME, these are connections are based on the different interfaces like the S1. So this is the basic architecture of the LTE system, right? So two parts are there, E-UTRAN and the EPC, the Evolved Packet Core. So in the little bit elaborated form we can see. And again, okay, one more thing which is very important in the LTE system. So when we talk about the LTE, so this supports the previous generation networks. Okay, LTE also comprise which can be use the previous network, just like the 2G network, 3G network, or the 2.G GPRS network and so on. Okay, so here we can see in this LTE network elements we have the radio access network and evolved packet core and the IMS internets. So in that the HLR and the HSS which can be interfaced between the evolved packet core. So that is, there is some interfaces are there. When we have the different gateways, if we are connecting with the cloud, so we have the SGI interface. For the HLR, HSS, which is the 2G network, home locator, register and so on. So for that we have the interfaces like the S6 interface are there. So for the interfacing between the servicing gateway, we have the interface S11. For servicing gateway to the PDN gateways, we have the interface S5. So we can see in the previous slide as well, we have the interface between the MME to the SG gateway and the P gateway, and here as well. So these interfaces are elaborated into this diagram, that servicing gateway or the S gateway, that is S gateway, the interface for that one is the S11, and servicing gateway and the PDN gateway we have the interfaces for the S5. And now we have the, as I said in the previous slide, we can see if I am talking about different E node Bs, right? So as I said, in the E node Bs we have the OFDM techniques, transmission technique can be used into it. So in the radio access networks, OFDM is used in that, where the different E node Bs are deployed. So these are the node Bs. When we, as I said, the 2G network, 3G network, these can be used into the LTE network as well. So LTE network support the previous generation networks as well. So it is simply representing that we have the node B, which is in the 3G networks, which is supporting the HSPA, high speed packet access networks, and OFDM networks when we are using the E node Bs. So this is the part of the 3.9G network, and you can say this is the part of your 3G network. So you can say this is comprises the 3.9, this is comprising the 3G networks, and this one can be comprised of the 2G networks, 2G network or 2.5G network and so on. So this is our main component of the LTE networks. Okay, So other interfaces also there, GR interface for SGSN to the HLR, S3 is for the SGSN to MME, S4 is between the SGSN to the servicing gateway interfaces, and S1U is the between the base station to the servicing gateway interface, and so on. There are various interfaces are there. These are network interfaces which connects wirelessly one component to the another component. So when we talk about elements of the LTE system, as we have discussed, the LTE encompasses the evolution where it consists of radio access through the E-UTRAN, which is nothing but the E-Node Bs, right? Then the non-radio aspects under the term system architecture evolution, SAE. So this is the one of the component of the LTE system. Then entire system composed of LTE, LTE and SAE is called the Evolved Packet System, EPS. So this EPS is nothing but this comprises the LTE and the SAE. SAE is the system architecture evolution. Okay, so for at the high level LTE network, when we talk about the high LTE advanced network, so in that way it can be used the access networks which comprise the E-UTRAN, as I said, and then the core network, CN. So core network, which is called the Evolved Packet Core, or sometimes it is called as the CN networks. Okay, core networks, so which are used, which comprise with the E-UTRAN, which is called the LTE system, which is a 4G network. In broad way, we call it the 4G network, but in realistic, it is a 3.9G network, because it is expected, it is, I mean, in this system, they have used the less data rate, which was expected more in the 4G network. That is why. UE, this is the user equipment, which is used to connect the EPS, Evolved Packet System. So this is an LTE capable UE. LTE network is comprised of the access networks, which is the E-Node B. Okay, so this E-Node B, that is Evolved RAN, consists of the single node and the E-Node Bs that interface with the UE. Okay, so this E-Node B is nothing but this is the one of the base station, and this base station is connected with the user or the mobile phone or the subscriber. So for that subscriber, we call it as the UE, user equipment. Okay, user equipment is there, which is a mobile phone subscriber. So there are different names in different generations they have given. So E-Node B, which hosts the physical layer, MAC layer, RLC layers, different layers can be supported to the E-Node B networks. Okay, so it handles radio resource management. So this is very interesting and very important feature in the LTE system, which the resource management, whatever resources are available, like the different bandwidth, different power, time constraints. So when we combine all this all together and when we are using it efficiently, then the resource management, it plays a very important role. And then the scheduling. So at what time, at what frequency the signal can be transmitted. So everything will be taken care by the radio resource management and the scheduling. Then we have the heart of the LTE system, that is the core network, which is Evolved Packet Core, or the EPC. So here we said there are three components basically, that is the MME, mobility management entity, S gateway, servicing gateways, packet gateways. Okay, so there are different interfaces when we connect all these together, right? So different interfaces are there which routes or forwarded the packets or the user data from one point to the another point into the networks. Okay, so that is a very interesting, very important features are there. Okay, so next very important point now, that is LTE technology. So in the LTE technology, what a transmission scheme, or how we transmit the data or high data rate signals. So for that we have transmission scheme, that is the OFDM. This is the orthogonal frequency division multiplexing. So in this method, what they have done, they have divided the complete bandwidth of the signal into the chunks of the bandwidth. So small, low, high, all in different way we can say. High data rate signals can be converted into the low data rate signals, and then we modulate those signals by the different subcarriers, right? So this is the feature of the OFDM system, and after that we combine all the signals and we transmit it. So why we require that? That is required for the low latency, lower latency, better spectral efficiency, right? So given bandwidth, maximum data can be transferred. So this is the basic definition of the spectral efficiency, which must be better. Then we have the MIMO, multiple input, multiple output. So what is the significance of that? In LTE system, it is used very efficiently as compared to the 3G system, where we are using the transmitting antennas. Here we are using the receive antenna. So more than one transmit antenna, more than one receive antenna, right? So this is the configuration of the MIMO system, which is a multiple input means multiple more number of transmitting antenna, and multiple output means more number of receiving antennas. So the different diversity techniques are used in the MIMO system. I mean, transmit diversity, receive diversity, space diversity, all different important diversities are used into the MIMO system when we evolved different antennas configurations into the MIMO system. So LTE uses the several transmit and the receive paths. As I said, the different diversity techniques are there. So this reduces the interference with increasing in spectral efficiency and the throughput. So when we are using the MIMO system and we combine the OFDM and the MIMO system, so in this way, because these are orthogonal in nature, right? So this is the orthogonal in nature, subcarriers are orthogonal in nature. It means when the one sample is taken care, so when we take the one sample in the OFDM system, the second sample will be taken when the first carrier has the null point. So when the first carrier has a null point, at that time the second sample can be taken. So in this way, what will happen? Overlapping of the signals will not occur and the ISI will be reduced. So this is the very important feature when we talk about the OFDM system. So this is a flatter architecture in the LTE. So fewer networks elements in the LTE evolved the EPC. So that is the LTE evolved EPC. This result in the lower latency, right, because of the lesser number of hops as compared to the 3G. Then absence of the RNC, which link the network element. So when the RNC is less, it means the complexity of the network is reduced in the LTE system. But RNC was there into the 3G system, right? So these things you have to keep in mind when we discuss about the LTE network. So in that in this network architecture, that is the E-UTRAN. So in that the user equipment, evolved E-Node Bs. So different functionalities are there for the E-Node Bs. User equipment is nothing but your mobile phone, your subscriber. These are user equipment in the LTE system or in the 4G network. Then we have the evolved E-Node B. So in that, what are the different functionality which it can be performed in the base station, right? So first one is a resource management, right? So in the resource management means how to allocate the different frequencies, how to utilize the different frequencies, and how to use the different handovers. Okay, when we are moving from one cell to another cell, so how the handover will take place. So these things will be taken care by the resource management. Then we have the admission control. Next is application of the negotiated uplink quality of service, cell information broadcasting, and last deciphering of the user and the control plane data, right? So the security is another very important feature into the LTE system, because all the different hops also used in that, so that it is very tough to detect the particular signal at what frequency we are detecting, right? So these all are the different architecture elements which is I am talking about. So network architecture evolved packets. So in that mobility management identity, what are the different functionalities in the in this network? We have the idle mode. First is the idle mode. In that, the UE tracking and the paging procedure, including the retransmissions of the signals which is lost somewhere due to some fading nature of the channel and so on. Different issues may be occur. So because of that, the retransmission continuously can be occurred when we have the mobility management identity. So it will happen through this one. Bearer activation and deactivation process which occur, and choice of the servicing gateway for the UE at the initial attach and at the time of intra LTE handover involved the core networks, right? So when we have the different, I mean, when there is a handoff between the within the LTE network, then it is the intra LTE handovers. If we have the handover from one LTE network to another LTE network, so these are inter LTE networks, but these things will be taken care by the core networks. So as we said in previous in 2G 3G networks, where we have the MSCs which taking care about the handover from one cell to the another cell. We have the core network into the LTE system will take care about the call forwarding, call receiving, and the call termination. So everything will take care by the core network. So this is the that is why this is the heart of the LTE system, as I said before. So authentication of the user, okay, so it checks the authentication of the UE to camp on the service providers, right? Public send mobile network. So this is one network which is into the LTE system, which is used to find the authentication of the user whenever the correct user is sending the data to another user, or is there any faulty things or anything which is not desirable for the network, LTE network. So these things will be taken care by this public land mobile networks, PLM, LMS. Then we have the control panel functionality for the mobility between the LTE and the 2G and 3G access. So this control panel functionality is this control panel is used for the accessing the previous networks, previous generation networks like the 2G and 3G, and it is accommodated with the 4G networks. So as I said, the 2G, 3G cannot support the 4G network, but the 4G network can support the 2G and 3G network. So this functionality can be taken care by the control plane functions for the into the LTE system. The servicing gateway, the functionality for that is the first is the routing and the forwarding user data packets. Second one is it acts as the mobility anchor for the user plane during the inter E not B, right? Inter E not B handover. So these are the functionality which we have to take care about. So when we design the networks into the LTE system, so for the mobility between the LTE and the other 3G networks, right? Then we have for the idle state, in this case, UEs, which terminates the downlink data path and triggers paging when the downlink data arrives for the UE. So in this for that one, as I said, the triggering the page, it means it is send the tones or the signaling information so that it can be confirmed in the when the complete data which is downlink from the base station it is received. Okay, it is arrived at the UE. Then in that case, it will send the this tone signals or the paging signal like the SMS which we send for the acknowledgement. It performs the replication of the user traffic in case of lawful interception, right? So if in case the data is lost somewhere, so in the or the someone has stolen the data in between the when it is sent by the transmitter or the receiver, a transmitter, and it is received by the receiver. So in that case, if something is lost, then the replication of the user traffic can be sent again and again. So acknowledgement must be received at the transmitting side so that it can confirm that the user has received the data at the correct order. Then packet data network gateway, which shows the different functionalities are there, which provides the connectivity to the UE external packet data towards the IP addresses, and UE may have the simultaneous connectivity with the more than one PDN gateways or the P gateways. Then it performs the policy enforcement, packet filtering for the each users, charging support, lawful interceptions, and packet screening. So all these things will be taken care by the packet data network. At the last, it acts as the anchor for mobility between the 3G and the non-3G technologies like WiMAX. So different multipath effects are there. As I said, when we have OFDM system or any other system which is used to reduce the ISI. Okay, so this ISI occurs when there is the overlapping between the signals. So this ISI inter-symbol interference, it can be reduced when we are using the when we have the frequency flat fading, when we talk about the scenario of the fading concept, right? So we have to convert the frequency selective fading into the flat fading when we have the multipath. So it shows the elimination of ISI problem, which can be used by the channel equalization, as I said. So when the ISI is introduced into the network, to avoid that ISI, we use the equalization network. So for that one, another solution for that one to reduce the ISI is the OFDM networks, right? So which is a very long symbol, and I have already discussed about the OFDM system in the last lecture. So this is the possible flexibility of the cellular bands which are used into the LTE system, and differently sized spectrum allocations are there, up to 20 megahertz for high data rates and the less than 5 megahertz for the migration from the 2G technology. So these bands are required for from 2G networks to any other network, but 20 megahertz is used for the high data rate network. So these scalable bandwidths are there, which I just said about the LTE network previously. So MIMO system, obviously it's very easy to understand. Different multiple antennas at the transmitter and the multiple antennas at the receiver. Simple concept is there. So high data rate, these are advantages of that. High data rate, spatial diversity. Some of the disadvantages is nothing but this is the complexity. So here there is the configuration for the LTE system when we have the different interfaces for the uplink 1x1. For the uplink, this is the MIMO system 1x1 and 1x2, or downlink system 1x1, 1x2, 2x2, 4x2. So these are the different MIMO configuration which is expected into the LTE system. So these are different techniques which are used in the LTE system. Single user MIMO, transmit diversity, closed loop rank 1, multi-user MIMO, and the beam width. So in this way, we can go further, that different channels, signals are introduced in that in downlink shared channel we have the PD-SCH, and the downlink control channel we have the PD-CCH. So downlink shared channel are used for different modulation schemes, and the physical downlink control channels which comprise the higher modulation schemes for the robustness of the signal. So common control physical channels, that is CC, PCH, which is responsible for the cell wide control information, and it uses the QPSK and transmit as close as center frequencies. Physical signals are sent nothing but for the references or the pilot signals. Also, this is used for the synchronization purposes. Transport channel, which is comprised the broadcast channel, downlink shared channel, paging, and the multicast. So these are the different transport channels which are used in the LTE system. And then finally uplink channels, in which the physical shared channels is there, physical uplink shared channel, physical uplink control channels are there, acknowledgements. So these all are the some features of the uplink channels which is used in that. Then uplink signals, which is random access preambles, which is added with the in front of the data which is need to be sent. And then finally reference signal, which is used to detect the signal at the receiver. So this is the architecture of the complete channel mapping, which I have just mentioned in the previous slide. Some of the advantages, which is very good in throughput, low latency, low operating cost. All IP networks can be utilized in that, and simplified upgrade path for the 3G network. These are services. Video services, low latency for the gaming, real-time video conferencing, machine-to-machine services, and these are devices which are used for the LTE network, like which contains the multi-mode, multi-band, dual stack. Greater number of devices can be used in the LTE system. So these all are the references which I have gone through. So I hope you understood this topic. So thank you very much.